Hello everyone, welcome to the video lecture series of course Internet of Things. In today's lecture, we are going to discuss Unit 6, that is application of IoT. In today's lecture, we are going to discuss topics home automation and smart city. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us discuss the content in the Unit 6, that is application of IoT. In this unit, we are going to study home automation, smart cities, energy, retail management, logistics, agriculture, health and lifestyle, industrial IoT, IoT design ethics, IoT in environmental protection. So now let us first discuss the home automation. IoT application has a diverse range of application. One of the most talked about and popular domain is home automation. Smart home, also known as home automation, uses some of core IoT services. It uses internet, embedded system, sensor, actuators, cloud, machine learning, etc. Home automation includes intrusion detection, smart lighting, smart home assistant, smart appliances, etc. Smart lighting introduction first. Smart lighting is an integral part of smart home. In its most advanced form, it saves energy by learning the habit of family member and by the ambient condition. It adapts the lighting condition by predefined rule, ambient condition or by the user preferences. In common adjusting scenarios, the system controls the lighting by dimming the lights or turning it on and off. LED lights are now popular and has become key enabler for smart lighting. IP-enabled lights are also contributing in making the home smart by making the lights identifiable remotely. Using IP-enabled lights, app can be used remotely, control and monitor the lights interactively. These are nothing but wireless connection or internet-enabled lights. They are now being widely used for saving energy by detecting the human movement and working or quiet hours. Smart lighting simulation using Arduino. A simple simulation of smart lighting can be practiced with the help of Arduino Uno board, resistor and LED, Arduino IDE. The specification of Arduino Uno is provided below. Figure shows the Arduino Uno board. Uno is considered as the most used board. It has heavy online documentation and community support. The Uno board is shown in figure. The Arduino Uno is a microcontroller board. It is based on the Atmega 328P microcontroller. The number of input and output pins in this board is 16. Out of these 16 pins, 6 can be used as a PWM pins. It has 6 analog inputs. It also has 16 MHz quartz crystal. USB connection, power jack, ICSP header, built-in LEDs and reset button are the other components on the board. These are depicted in the figure shown. The figure shows the components on Arduino Uno board. This board can be started by just connecting the USB slot of computer with the provided USB cable. It can also be powered by AC-DC adapter. The board is programmable with the Arduino IDE, that is Integrated Development Environment. Currently, it uses a Type B USB cable. Uno means one in Italian and it marks first release its supporting Arduino software IDE, that is Arduino IDE 1.0. The Atmega 328P microcontroller in Arduino Uno comes with inbuilt bootloader that allows the easy boot. It does not require any external program loader. The communication protocol is original STK500. The pin function of the Arduino Uno is provided below. LED. The built-in LED on Arduino is controlled by pin 13 and high voltage, that is 1, on the pin causes it to glow. Low, that is 0, turn it off. Power. Power for operation can either be provided by the 5-volt USB or by external jack of 17 to 12 volt. 3V3. 3.3 volt is generated by the onboard regulator. 50 milliampere is the maximum current draw. GND, that is ground. The pin signifies the ground. VIN. VIN signifies the input voltage. This pin can be used to supply power from any external source. Reset. The reset button or pin is used to reset the device. In case of blockage, it can be used. IOREF. This signifies the voltage reference for the microcontroller to operate. Arduino IDE is the popular IDE used to communicate, write and upload program on the Arduino board. This is very convenient IDE for beginners. This IDE supports the C and C++ like structure for Arduino programs. Language rules are simple and can be easily learned. The IDE itself is primarily developed in Java. Few parts are also written in C and C++. This is an open source IDE and source is available under GNU's GPL, that is General Public License. Automatic identing, brace matching and syntax highlighting are the few of the common features in this IDE. On-click upload of program on board is supported by the IDE. GNU toolchain is also included in the IDE for building the programs. ABRDUDE is one specific program included in IDE. This program has the responsible of converting executable code into text of hexadecimal encoding. This encoded program is loaded into board by a loader program available in board's firmware. Smart Lightning simulation setup using Arduino. Arduino pins can be configured as either input or output. In that sense, these pins are called general purpose input-output pins. Following sketch, an Arduino program has programmed the digital pin 12 or GPIO pin 12 as output using the function pin mode. Later on, the same pin can be used to blink connected LED by using the function digital write. The code of the GPIO programming code is shown below. In program the pin 12 as an output and blink the external LED. Use breadboard, external LED and register for this purpose. The connection will be shown in the figure next. The setup function runs once when you press reset or power the board. Void setup, that is initialize digital pin LED underscore built in as an output. Pin mode 12 is used as an output. The loop function runs over and over again forever, therefore void loop. Digital write 12 high, that means it turns the LED on high as voltage level. Delay of 5000, that is it will wait for a second. Digital write 12 low, it turns the LED off by making the voltage low. Delay of 5000, that is it will wait for a second. The setup of the configuration is shown below. More sensors can be connected to set up so that the environmental condition can cause the LED blink. It should be noted that the above setup and program are used to achieve a simple objective, that is blinking the LED at a fixed interval. The objective can be widened by including various sensors to the setup and by adding the relevant code so that LED can be blinked based on environmental conditions. Intrusion detection. The primary objective of home intrusion detection system is to develop an IoT system which can detect the intrusion with the help of sensors. The system includes a software system, a sensor, network and other required hardware. There can be multiple ways of implementing home detection system. It will be depend on feasibility, availability, environment and financial resources. The primary hardware components of the intrusion detection system is camera, PIR sensor, door sensor and an embedded board with sufficient resources like processor and memory. These sensors need to be properly physically placed so that it can detect the intrusion effectively. The sensor and camera are interfered with the embedded board which is connected to the internet. User interfacing device like mobile app or alarming system should be connected to the network. Alerts related to the intrusion can be sent to the user's app, that is app notification, SMS or email. Most preferable way can be alarming system within the home premises or the nearest security station. More additional features can be to be basic intrusion detection system like capturing the image and sending it to email attachment. Nowadays, even instant messaging app can receive images from other automated system. This can be quite effective solution by notifying the intrusion detection. One possible process specification diagram of the home intrusion detection system is shown in figure. The figure shows the process specification diagram for home intrusion detection, that is door sensor. This is for the door sensor which will simply detect the door is open, generates an alert by creating an event called door open event. Let us have a look on the process flow diagram. Similarly, for motion detection sensor is read by the application. Event is generated and alert is sent to the desired format to the required register device. The process specification diagram is shown in figure. The figure shows the process specification diagram for home intrusion detection, that is motion sensor. The possible deployment diagram of the intrusion detection system with two primary sensors, that is door and motion, is shown in figure. The figure shows the basic deployment diagram of the home intrusion detection system. The communication between the local embedded system and cloud application is assumed to be a REST communication. However, different implementation of intrusion detection system may opt for different communication mechanism and protocol. Now let us discuss the smart cities. Smart city. Smart city is the collection of many IoT application scenarios. It includes smart parking, smart lighting, smart road, smart surveillance, smart waste management, and energy management. Security, privacy, and trust in IoT data platforms for smart cities. Smart cities different solution for various day-to-day life problems and important data management aspects. Data in smart city prospect is gathered from several sources owned by numerous administrative domains. Public and private transport system within the city, public camera surveillance, location-based data collected from mobile app of users, electricity, water distribution within the city, power management, etc. There are large data collected that needs to be properly managed so as to use it for improvement of city. The vast data generated in smart city is stored in distributed manner. It can be stored locally on SD card provided with censored boards, remotely on company server, social network, some private data centers, or even on the cloud storage space. Figure shows the smart city architecture. As it is clear from the smart city architecture, data and information generated within the process need to cross multiple platforms throughout its life cycle. As at each step, data and information can be used for different purposes. So no data or information generated in the process can be coined as useless. Also, decisive information can be generated within the scope of the data providers or many control centers. So, to facilitate sharing within the smart grid, a sharing platform is necessary. This data sharing platform is used to transfer the data or information from various data administrative boundaries in secure and private environment. Due to such importance in IoT applications, smart cities, security and privacy needs to be integral part of application design which may not be added later. A strong mechanism for trust and reliability is needed for all stakeholders as well as devices, starting from sensor, actuators and other smart objects to end users and service providers. For example, user might be ready to share his/her constant updating location data via GPS to his/her family or friend, but same cannot be said for any third party service provider. User might not want to share such data with any unknown or known service provider. Interaction between multiple domains in smart cities via sharing this data or information will lead to development of more innovative application. But such sharing needs to be fully secure, and IoT-based sharing needs special attention. Risk in smart city IoT platform. The storage is moving towards cloud as it provides high scalability, higher computational interface, and cheaper maintenance and operational cost. But with this, there comes pros and cons of cloud computing. Additional layer of cloud security is added, but threats to clouds are also added to smart cities data management. Security risks like breach of security of cloud servers or data manipulation by internal attackers is imminent to such condition, which poses a challenge. Smart city gather huge data from sensors and the actuator distributed throughout the cities, which needs authorized and authenticated way of access. This should enable trusted information sharing and access in privacy perceiving ways. The breach of security in such environment can lead to an uncontrollable disaster, ranging from immediate interference in communication, leak of private data to major dysfunction in public transport or even loss in human lives. Attackers might focus on following points to cause havoc: obtain private data with malicious request, attack actuators or sensor in physical environment to damage devices or to obtain data directly. Man in the middle attack where attackers impersonate a smart device, manipulate sensor data to falsely carry out unwanted work in a well-behaved city. As IoT is vastly distributed, firewalls, monitoring tools, and access control lists are not enough to prevent high-level attacks. It is extremely important that security measurements should be implemented as a core part of the IoT application in its design. Smart transportation in smart city. Smart cities, transportation objectives improve the public transport management and to provide cost and time benefits to the travelers. Linking users' smartphones to gather additional data about the journey. Provide location-based traffic services to the car users to reduce the traveling time and minimize the traffic congestion. Effective use for traffic control system in planned and unplanned scenarios, planned like road maintenance and unplanned like accidents. Usage. Public transport companies can monitor the current demand of travelers for any route and can increase the number of vehicles for the route according to the need. Monitoring location of public transport vehicle. Keep traveler smartphone updated with the information like current position of the bus, estimated traveling time, current traffic condition, etc. City traffic officials can monitor current traffic scenario and to better the traffic flow using signals and indicates any detour if any road construction or maintenance is in the process. Security and privacy challenges. Location-based data of public vehicles should be accessible to individuals based on accessibility policy and privacy rules. Data exchange between sensors, actuators, and servers should be a secured communication. All the information related to location of travelers should be strictly private and must be shared only with the user consents. Integration of data and communication between public transport companies and private companies involved in this service should be a long distance communication service. Data aggregation for IoT in smart city and security. IoT is going to play a major role in developing smart cities. In fact, the concept and the implementation of smart city is based entirely on project implementation. The knowledge society and information-based business along with IoT works together to visualize and implement smart cities. Smart city implementation requires IoT system to obtain data from various sources, manage and aggregate it to fulfill the high-level objective and requirement. Data aggregation in IoT for smart city implementation poses many challenges like treating the raw data uniformly from heterogeneous resources, security privacy issues associated with data and huge amount of data. Challenges related to privacy, trust and reliability are also matter of major concern in IoT data aggregation. The identified challenges are: for efficient reuse of data among various smart city IoT subsystems, a shared information model need to be implanted. Such shared information model will be incorporate trust as well as it will maintain quality of information. A communication model that will provide the required level of security to transfer the data between the IoT devices. A mechanism for protection of devices and systems which are involved in data integration and consumption in IoT system. Another major concern in smart city technology data aggregation is to provide optimization mechanism for data at different level of data management. It is possible that the data is getting obtained from various sources which falls under administrative policies. Efficient acquiring mechanisms under specified policies is essential for successful aggregation of data. Often service providers play an important role in implementing security and trust. A large smart city can be visualized as a large information system where many service providers are offering data to be used by others. If trust and security policies are clearly understood and implemented at service provider side, aggregation tasks can be significantly simplified. Risk to smart city IoT platform. Most of the IoT systems which involves heavy exchange and reuse if data involves the service of cloud platforms. Implementation of smart cities are not an exception. Cloud as a platforms as a service, software as a service, sensing as a service, and more IoT-oriented services are quite helpful achieving scalability but have associated risks. Customer has to rely on the third-party trust and security model. Furthermore, the data ownership among different information systems remains unclear in many large IoT implementation scenarios like smart cities. Reliability of sensor data providers and other information systems also involves certain degree of risk as these are the most crucial in smart city functional implantation. Wrong data may result in catastrophic events. Hackers and attackers may specifically target on information system to take control of physical object and real time event in the smart cities. A digital and automated control of smart city hence has inherent risk. Following are the associated identified risks in different layers. Attackers may attempt to modify the sensor data to achieve the desired alteration and actuation in operation of IoT system. Physical interaction with sensor and actuators by attackers to get the private information of users. Man in the middle attack by attackers by impersonating network component. Generating malicious requests by attackers for shared information system and obtaining sensitive data. Security. The last section has briefly overviewed the risk associated with aggregation of data in IoT for smart city implementation. This section will specifically address the security issues and steps involved in obtaining the secure platform for IoT system in smart city implementation. One of the most important aspects of implementing security in such system is to ensure that different owners of data are cooperating with each to implement a secure platform. This system of cooperation often termed as a SOS, that is systems of systems. This system of systems may be implemented by independent organization. It is an attempt to bring all information system stakeholders at a single platform so that they can start implanting the standardizing mechanism of security. The major aspect which needs to be covered for the security implantation by SOS or any similar group is specified below. Availability. The availability specifies that correct and required service should be available always for IoT smart city system. Reliability. The correct service which are required by IoT system for smart city implantation should be available always in continuation. Safety. There should not be any scope of catastrophic consequences of any event. And in ideal case, there is zero tolerance for system failure. Missing the hard deadline cannot be afforded at any cost in such system implementation. Integrity. The IoT system should not get corrupted at any cost. System alteration by external entities should never be allowed intentionally or unintentionally. Maintainability. There should be proper implementation of mechanism by which system will get upgraded and repaired. Summary of today's lecture. In today's lecture, we discuss smart lighting introduction, smart lighting simulation using Arduino, smart lighting simulation setup using Arduino, intrusion detection, smart city, security, privacy and trust in IoT data platforms for smart cities, risk in smart city IoT platform, smart transportation in smart city, data aggregation for IoT in smart city and security, risk in smart city IoT platform, and last we discuss the security. Thank you.